In section 4.7, we're going to look at something called the quotient rule. Now, the quotient rule is very similar to the rule we learned in 4.6, which was the product rule, except obviously in this case we're going to deal with a quotient. So first of all, I'll just state the quotient rule for you. The quotient rule says if you have a function f of x, and that function can be expressed as a quotient, so some function p of x divided by some function q of x. And you're asked to differentiate that function. So the quotient rule says then the derivative f prime is equal to, now just like the product rule, it's simply a rule. It's not difficult. You just have to memorize the rule. It's very similar to the product rule. In fact, you'll notice that there's a lot of similarity, especially in the beginning. The rule starts by saying take the numerator of your quotient and differentiate it. So we're going to go p prime of q. Then we're going to multiply that by the denominator without taking its derivative. So we're going to multiply it by q of x. You'll notice that that's identical to the product rule, except with the product rule it wasn't p over q, it was p times q, but we did the same thing. And then, probably not surprising to you, that often in math when we're dividing we associate that with subtraction, laws of exponents, etc. There's going to be a minus sign, and then we're going to reverse it, and we're going to go q prime of x times p of x. Now, if we were to stop right there, that rule would look very similar to the product rule, except for the minus sign. The difference now is that we have to divide all of that by whatever's in the denominator, q of x, and then we square that result. And there you have it. That's the rule for differentiating the quotient of two functions. So what would that look like as an example? So let's say we had, for example, let's say we had the function y equals x cubed divided by x squared minus 1. Okay, so the x cubed, the numerator, is p. That's the function p. And the x squared minus 1 in the denominator, that's the function q. So what we have here is a function, x cubed, being divided by another function, x squared minus 1. And we want to take the derivative. So the derivative, dy dx, would be equal to, now the quotient rule says, take your numerator p and differentiate it. So ignore the denominator and just take the derivative of x cubed. So x cubed is just a power, so the derivative would be 3x squared. Multiply that by the denominator without taking its derivative. So x squared minus 1. Subtract. And now just reverse the process. Take the derivative of the denominator. The denominator is two terms, x squared subtract 1. The derivative of x squared is 2x. The derivative of minus 1 is 0. It's a constant. So we just get 2x times the numerator, x cubed, all divided by the denominator, x squared minus 1, all squared. And that's it. That's the derivative of that function using the quotient rule. I'd like to talk a little bit at this point about what would be expected of you. On a test, when you write your Chapter 4 exam, a good portion of the exam will just be testing you on your rules. If I was testing you on your knowledge of the quotient rule, I wouldn't ask you to simplify it. So this answer right here, this is said to be in unsimplified form. So if you see that instruction where it says differentiate but leave your answer in unsimplified form, then that means you don't have to do anything to the answer. You can just leave it in the form, in its raw form of what you would get after you take the derivative. There will be, however, a few questions on your test, and if you look at your textbook, you'll see that that's also expected of you, that you have to be able to take your differentiated answer and write it in what's called simplest factored form. Now, simplest factored form, we'll see later when we get into the application part of the course, is crucial. It's one thing to know how to take a derivative, but it's absolutely crucial that you can take that derivative and write it in a simpler version, a simplest factored version. The way you do that is you take out common factors. If you look at the numerator, there are two factors, 3x squared and x squared minus 1. And here there are two factors. And you ask yourself, is there anything that's common? Well, there's an x squared here, and there's an x squared in that x cubed. So I can take out the x squared as a GCF, a greatest common factor, and I'll be left with 3 times x squared minus 1 minus 2 times x, all over x squared minus 1 squared. This bracket that I have after I take out my GCF, that has to also be simplified. So we would write x squared times, now if you distribute the 3, you'll have 3x squared. And sorry, I made a mistake here. That should be 2x squared. This was x times x cubed, which is x to the 4th. And I took out an x squared, so that should be x squared. We're going to have 3x squared take away 2x squared, which will just be x squared. And we're going to have minus 3. This answer right here, this answer is in factored form. Everything is written as a product. We have x squared times x squared minus 3 over the factors x squared minus 1 squared. This answer is called simplest factored form. And so I just want to clarify that for the purposes of your Chapter 4 test, a lot of your Chapter 4 test will just be, do you know how to apply the rules? Do you know the quotient rule, for example? So if I was testing you on your knowledge of the quotient rule, I would have you stop right here. That tells me that you understand the basic rule. But there will be a couple questions, pretty small compared to the majority of the test, but there will be a couple questions where you'll be asked to write your answer in simplest factored form. This is going to become very crucial as we proceed through the course, so it's something that you should be practicing at this point. When you're doing questions in the textbook, they will sometimes ask you to leave your answer in unsimplified form. Sometimes they'll ask you to simplify it. So just pay attention to what the instructions are. I would not be simplifying every single question that I did.